this section here is a review for you guys. So we're going to start with completing the square, which was one of the topics we covered in college algebra. Okay, so we have this problem here, x squared plus 2x equals 5. So the first thing that we want to do here is isolate the constant. So our constant is 5, so that is already isolated. So we can kind of skip through that step there. The next thing we're going to do is we're going to find b over 2 squared, and then we're going to add it to both sides. Okay, so our b value, okay, in our quadratic here, remember your quadratic is given by ax squared plus bx plus c equals 0. So the b is going to be this value right here next to the x. So we're going to take our b, which is going to be in this case 2. We're going to go 2 over 2, and then we're going to square it. So 2 over 2 is going to give us 1. 1 squared is going to give us 1. So we're going to take that and we're going to add it to both sides. Okay, which means that I am going to do this. I'm going to have x squared plus 2x plus 1. I'm add it on that side, and then I'm going to have on the other side 5 plus 1. Okay, then our next step is going to be to factor on the left. So when I factor on the left, I should have a perfect square trinomial, meaning that the numbers here are going to be the same for my values here. So if I'm factoring this, I have x and x, and I want to say what multiplies to 1 and adds a 2. Okay, so we only have one thing that multiplies to 1, which is 1 times 1. 1 plus 1 happens to be 2. So we say this is x plus 1, x plus 1. Okay, the way we want to write this, however, is we want to go x plus 1 squared, because we're writing it twice. And then step 3a, or 3b, is 5 plus 1. Make sure you add that on the left. So that'll be 6. Okay, then we solve using the square root property. So the square root property tells us to first isolate the square root term, which it should already be isolated here. Then second, take the square root of both sides. So here I'm going to take the square root of the left and the right. On the left, it will free up x plus 1. And then on the right, I'm going to get a plus or minus. Erase that real quick. There we go. The square root of 6. Okay, so we don't want to forget that plus or minus. Then the next thing we do is we solve for x. I'm going to take this plus 1 and I'm going to subtract it. Notice I left a little room over here. So I'm going to subtract the 1 from both sides. And I'm going to put it in front of this plus or minus square root of 6. So it's going to give me x equals plus or minus the square root, negative 1 plus or minus the square root of 6. Now the very last step would be to simplify this radical, if I could simplify it. But in this case, I cannot simplify it, so this is going to be my final answer. Kind of hard to look at the screen that way. I'm going to look this way. Okay, so let's look at another example of completing the square. Okay, we have x plus 7 equals 10x. Or sorry, x squared plus 7. So what we want to do here is we want to isolate the constant. Now in this case, the constant is 7. Okay, so we want to actually subtract the 7, and we want to move that 10x over, so we're going to subtract that as well. So my problem is going to look like this. X squared minus 10x equals negative 7. Notice I left some room here, and that's because I'm going to add something right here. And I'm also going to add something right here. I just have to find what that is. Okay, then I'll do that step, that b over 2 squared step. So my b here is going to be negative 10. So I'm going to go negative 10 over 2, and I'm going to square that. So that's going to be a negative 5 squared, which is going to give me what? 25. Just making sure you're paying attention. So we're going to add 25 to both sides. Okay, then we're going to factor on the left. So we want to say we've got two factors. This should be a perfect square trinomial. That's going to multiply to positive 25 and add to negative 10. That's going to be what? Negative 5, yeah. So x minus 5 squared, because negative 5 times negative 5 is going to give me a positive 25. Negative 5 minus 5 will give me negative 10. And then what is negative 7 plus 25? 18. All right, then we're going to do our next step, which is to take the square root, both sides, don't forget, plus or minus. That frees your x minus 5 from that squared term. This is just x minus 5. Equals, leave a little bit of space, plus or minus, radical 18. Take that minus 5, add it to both sides. So there we get a 5 plus or minus the square root of 18. Awesome, hello. All right, so then what we want to do is we want to simplify the square root of 18. So you guys have been taught different ways of simplifying these, right? So if you've had me before, my method is taking the largest square root and pulling that out. Some other teachers just teach you to make a factor tree. If you have any doubles, that's your perfect square. So if that's the way you like to do it, that's fine. The way we're going to do that in this class is we take our perfect squares, pull them out, so we make a factor tree, but only with the perfect squares. Okay, so that means you need to memorize your perfect squares. So I'm just going to write them over here to the side. We have a little reference here. So 1 squared, that goes into everything. So we're going to start with 2 squared, then 3 squared, 4 squared, 5 squared, 6 squared, 7 squared. Then we got 8, 9 is 81, 10 is 100, 11 is 121. Let's see here, 12 is 144. We're going to go to 15. So you have it for your reference. 13 is 169, 14, 196, 15, 225. So which of these values goes into 18? 9. So we break that up into 9 times 2 would give us 18. Okay, and they're both still under the radical since we're breaking them up underneath the radical. So we take the square root of the one that's the perfect square. Okay, so that square, perfect square is 9. So this becomes a 3 radical or root 2. So then our answer here is going to be x equals 5 plus or minus 3 radical 2. So if I enter in my homework this 5 plus or minus radical 18, it's going to get marked wrong. Okay, if you put it on a test, you're going to get partial credit, but not full credit. Okay, so we want to make sure we always fully simplify as much as we can. So example 3 has us determine the number that should be added to complete the square and then factor. So we're not actually completing the square, we don't have an equal sign, we just want to find those numbers. So determining the number is going to be taking that b over 2 and then squaring it. So what's my b value there? 18. So 18 over 2 is going to give us 9. And 9 squared? 1. So then if I were to factor, so this is the first part. So if I were to factor this expression, x squared plus 18x plus 81, what would that give me? Good, yeah. 9 times 9 is 81. 9 plus 9 is 18. So it would be twice. All right, and then the next thing we have is just some factoring practice. So we have 98 minus 18x squared. We want to factor that. So let's see here. First thing you always want to check when you're factoring is if you can pull out a GCF. Do I have a GCF I can pull out of there? I know they're both at least divisible by 2. Is there anything larger? 6? Well, it might be. I'm not sure. No, 98 doesn't have 6. What about a 3? Nope. What else goes in 18? So you got 2, 3, 6, and 9. Nope, so it's going to be 2. So 98 divided by 2. Okay, so we can take a 2 out of there. Okay, which means we're just dividing both of these by 2. So all right, so that's going to give me a 49 minus 9x squared. And do you notice anything about the 49 and the 9x squared? Yeah, they're both perfect squares, but the x squared's on the wrong side, right? So I have to change that. Let's take a look when we change it. See what happens here. So this is a negative 18x squared, a positive 98. So if I divide both of these by 2, I get a negative 9x squared plus 49. Now, still not exactly right, because what I want to do here with 2 terms is I want that sum or difference of squares. I actually want to, let's see what happens when I take out a negative 2. So if I were to divide both of these by negative 2, then this would give me a positive 9x squared, and this would give me a negative 49. Now I can factor that, okay? So I couldn't factor it before with a negative in front of the 9x squared because it wasn't in the right form for my sum or difference of squares, okay? So what I can do now, or sorry, it's just difference of squares, sum or difference of cubes, is I can take these and I can take the square root of both of these, so the square root of 9x squared, 3x, what's the square root of 49? 7. And that is difference of squares, which means the middle term canceled out, and the only way it did that is if these were opposite signs. So now I'm fully factored. So I have the negative 2 that I pulled out, and then that allowed you to use difference of squares. You can get 3x plus 7, 3x minus 7. Okay, then example 5, we have a non-monic trinomial. And there's 2 ways to factor this, and everybody likes different ways. And I like using the mistake method, but a lot of my students don't. So I'm going to do both. All right. Let's start with, we'll start with the AC method. Okay, so this first method is the AC method, or it could be called the factor diamond, or the factor X method, or the X method. There's a lot of different words for it. But typically, here's what you're going to do. So you're going to make kind of a big X, and you can surround that with a diamond if you like. In the top of this, you're going to do A times C, and in the bottom, you're going to put your B. Okay, so A times C is going to be 3, and you're just pulling the coefficients. So 3 times 20, or negative 20, gives us a negative 60. And then in the bottom, your B value, negative 7. Then what you're going to do is you're going to find in the sides, okay, the numbers that are going to multiply to negative 60, but add to negative 7. Okay, so I want to find my factors of 60. So let's see, I've got 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, which I think are probably going to work because they have a difference of 7. 6 and 10 has a difference of 4. 7 doesn't go in, 8 doesn't go in. Yeah, that's it. So I'm thinking 5 and 7 because I need them to add to 7. But am I going to do, or sorry, 5 and 12. 5 minus 12 or 12 minus 5? 5 minus 12, yeah. So I want a positive 5, negative 12. So 5 times negative 12 gives me that negative 60. And then 5 minus 12 gives me that negative 7. Okay, so I'm putting those in the sides. Doesn't matter which side you put which. Okay. And then here's what I'm going to do with them. So I'm going to go back here to my problem, which is 3x squared minus 7x minus 20. These are going to split that middle term. Okay, so that middle term becomes a positive 5x minus 12x. So it's almost like I FOILed it. I'm just going backwards. Okay, that was the step before I added those two like terms together. Then I'm going to pull down that 3x squared and that minus 20. And then I'm going to factor by grouping. Which means I'm going to split the middle term, pull a GCF out of each side. So I can pull, what can I pull out of there? Just an x. So it's going to give me x, then 3x squared divided by x gives me 3x. 5x divided by x gives me 5. What can I pull out of here? 4. I can pull 4, and yes, it should be negative. Because remember, you want what's in parentheses to match up. So when you pull the negative 4 out, you got negative 12 divided by negative 4, which gives you a positive 3x. Negative 20 divided by negative 4, which gives you a positive 5. And then you have your two factors. You have x minus 4, and you have 3x plus 5. You write that one once. Okay, so that's your AC method, or whatever you want to call it. Well, let me write this down for the mistake method. Okay, and then this next method is called the mistake method. You can use either one you want. It doesn't matter. I'll switch which one I'm using as we go through this stuff. So if you get familiar with both, even better. Okay, because you want to be able to do a lot of factoring, especially as you keep going, because it never goes away. All right, so for the mistake method, you start pretty much the same way that you would with the AC method. So you're going to do this. You're going to take, what I do is I just kind of draw a thing here, and you just multiply 3 times negative 20, negative 60, and then you find your factors that are going to add to negative 7, also multiply to negative 60. So we say we went through that, and we found our factors. We found that it was plus 5 minus 12. what we do here is we pretend that we were doing it like it was a monic binomial. So we set it up with our x and our x, and then we plop those numbers in. So we got +5 and a -12. Okay, then we say, oh, I made a mistake. I forgot it's not monic. I forgot the 3. So then you have to include the 3. So what you do is you take the 3, put it underneath these numbers you plop down, and then you simplify. So 5/3 does not simplify. So what you're going to do there is you're going to take that 3, put it in front of the x. 3x plus 5. -12/3 simplifies. That's just 4. X minus 4. There's your factors. So I like it better because it's faster. Okay, and whatever way you want to do it, that's fine with me. And is that everything for this?